So page replacement algorithm, operating system. So in that page replacement algorithm, what is that page replacement algorithm is? So very first thing we need to understand that comes in the page as a virtual memory, right? So what happens here if so this CPU, so this is an CPU. Here we have a RAM. Okay, so RAM is of a different size. So and then we have here so the secondary storage, right? So whatever process we have, so the whole process we cannot store or we cannot store in a RAM. So that's why. So we will store part of the project in the secondary memory and part of the project we can store in this so RAM. Okay. So and then we can execute the whole process. Okay. So that is the concept of virtualization. Means so here what happens if you have a project, so that is a huge long project. Okay. So then that has to be run in a RAM of having a small capacity, right? So if you take RAM, that is of 1 GB. So and if a project has our process has the size more than 1 GB, it may be 4 GB, 5 GB. Then what you will do? You will store that one in the secondary storage. Okay. So and when you want to execute that project, so then what CPU will do is CPU will request so for that project a page by page. We will divide that whole process into different pages, and we will store that one in the secondary storage. And then the CPU first it will ask for page 1, then page 2, or then it may require page 4, page 5, page 6. So that we will say that so this is what the stream of pages referenced by this CPU. CPU in ಮಾಡುತ್ತೆ ಕೇಳುತ್ತೆ and first page goes second page or fourth page or fifth page. So like that, whichever page it requires for the execution, that it will so reference for that page. So then that see for execution CPU check for these pages in this RAM. Suppose if the RAM can store only 3 pages, right? So then it will check for 3 pages here. So then if the particular page is not available in this RAM means, then it has to go to the so secondary storage, and then it will search for that particular page. Then it will replace the existing page. So whichever page is there here, that is replaced with the new one. Okay. Suppose if these things are loaded here, page 1, 2, 3 are loaded, and if it wants page 4, right? So then it will search for the secondary storage for page 4, then it will come with that page, and then it will replace one of these 3, then it will put that page here, right? So then which one to replace? That question comes, right? So which one to replace here? So then for that answer, the different algorithms are there. Those algorithms are page replacement algorithms. So what are those page replacement algorithms we have? So first one we will study FIFO algorithm. So then LRU. So then optimal page replacement algorithm. Okay. So FIFO page replacement algorithm, LRU page replacement algorithm, and optimal page replacement algorithm. So then, so ನಿಮಗೆ ಭಯ ಆಗ್ಬೋದಾ ಏನು ಇಷ್ಟುದ್ದ ಸ್ಟ್ರಿಂಗ್ ಇದೆಯಲ್ಲ ಸರ್ ಹೇಗೆ ಮಾಡೋದು ಇಷ್ಟುದ್ದ ಇದೆ ಸ್ಟ್ರಿಂಗ್ ಸೊ ಅದನ್ನು ಯಾವ ರೀತಿ ಪ್ರೋಸೆಸ್ ಮಾಡ್ಬೋದು ಸೊ ಯು ಮೇ ಫೀಲ್ ಡಿಫಿಕಲ್ಟ್ ಬೈ ಸೀಯಿಂಗ್ ದಿಸ್ ಒನ್ ರೈಟ್ ಸೊ ಇಟ್ಸ್ ಕ್ವೈಟ್ ಸಿಂಪಲ್ ನೀಡ್ ನಾಟ್ ಟು ವರಿ ಅಬೌಟ್ so this question, okay, just try to understand this question and then how to solve this. So consider the following page replacement stream. This is what this stream, whatever just now I explained. CPU request for this reference, then this reference, this reference, this reference. So like that it is referring for this stream. So then ultimately, how many page fault? Okay, so how many page fault would occur? So and then he says that assume 3 frames. Okay, so which one of the, and then assume 3 frames, and then he says which one of the above is most efficient. So these are the 3 questions are there. First question is how many page fault would occur. Okay. So then, so criteria here is given. Assume 3 frames. Either we can assume 3 frame, 4 frame, 5 frame. So whatever the in question they will specify, that we can consider. So and then which one of the is efficient, that we need to answer for that one. Okay. So first thing, take model. 3 algorithms in there. So so FIFO and then LRU ಮತ್ತೆ ಆಪ್ಟಿಮಲ್. ಈ ಮೂರನ್ನ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಸೊ ಒಂದೊಂದನ್ನು ಕೇಳ್ಬೋದು, ಇಲ್ಲ ಒಟ್ಟಿಗೆ ಕೇಳೋದು ಜಾಸ್ತಿ. ಮೂರನ್ನು ಒಂದು ಸ್ಟಿಕ್ ಕೊಟ್ಟು ಮೂರನ್ನು ಮಾಡಿ ಅಂತ ಹೇಳಿದೆ. ಸೊ ಫಸ್ಟ್ ನೀವೇನು ಮಾಡಬೇಕು, ಫಸ್ಟ್ ಯು ನೀಡ್ ಟು ಕಾಪಿ ದ ಸ್ಟ್ರಿಂಗ್, ಸೇಮ್ ಸ್ಟ್ರಿಂಗ್. ಓಕೆ, ಟೇಕ್ ದಿಸ್ ಒನ್ ಒನ್ಸ್ ಅಗೇನ್. ಓಕೆ, ಸೊ 1 2 3 4 2 1 5 6 2 1 2 3 7 6 3 2 1 2 3 6. Right. So now 3 frames he says. So that's fine. So frame F1, F2, F3. Okay. So this is what this is what the frame with 3 frames. That's it. It can store maximum of 3 pages. Okay. If you want 4 frames, then you can increase one more. That's it. So this is what frame 4. So even you can make frame 5. So okay. So that is the 3 frames. So now very first thing. So this is what 3 frame is. Okay. So very first thing, there is nothing is there in the frame. Okay. So CPU is asking that frame 1 is required, and that is not there in this list. Initially it is empty, right? And we will load that one in the RAM. Okay, we will load that one. So that is frame 1 is loaded here. So next CPU is asking for 2. Just we can see here it's that. So CPU is asking for frame 2, right? So then already frame 1 is there. Then we need another 2. Got it? So next, so CPU is asking for frame 3. So we have 1, we have 2. Then another one is also empty, right? So we can put that one, right? So whenever the CPU is referencing for that string, if that is not there, means that we can say page fault. Okay, for that one we will refer it as page fault as that is. See, one irrilla ಇದೆ, so then page fault occur. Just I will refer that one in star mark. Okay, so then it is referring for 2. Again the page fault is occurred. Page fault ಅಂದ್ರೇನು, CPU ಬೇಕಾಗಿರೋ ಪೇಜ್ ಅಲ್ಲಿ ಇಲ್ಲ ಅಂದರೆ ಸೊ ಅವಾಗ ಅದನ್ನು ಸ್ಟೋರ್ ಮಾಡ್ತೀವಿ ಸೆಕೆಂಡರಿ ಸ್ಟೋರೇಜ್ ಇಲ್ಲ, ಅದನ್ನೇ ನಾವು ಪೇಜ್ ಫಾಲ್ಟ್ ಅಂತ ಅನ್ಕೋತೀವಿ, ರೈಟ್? ಸೊ ಥರ್ಡ್ ಒನ್, ಸೊ ಅಗೈನ್ ದಿಸ್ ಇಸ್ ಆಲ್ಸೋ page fault because 3 is not there, right? So in these 3 frames, all these 3 are filled around. So then CPU is referring for 4. Okay, so 4 is there here? No, not there, right? So then we need to load that one. So to load that one, which one to replace first? So according to this FIFO page replacement says that whichever comes first in, first out, right? Whichever comes first, you replace with that one. Okay, replace with that one. That is with the new one. Okay, so which one came first among these things? We know that. So the one is came first, right? Then came 2. So then came 3. So then we will replace this one. Okay, so this one is replaced. Okay, so with the 4. That's it. So then keep these things as it is. Again it is a page fault, right? So next CPU referencing for 2. 2 is there? Yes, it is there. So then it is not a page fault. Then as it is you can copy here, or you can leave as it is. Okay, 4 2 3. That's it. So next we want 1. So is there 1? No. So then page fault occur. So then replace. Which one to replace? Among these things, which one came first? So that is what? First in, first out, right? So this is what came first, right? So in this place you replace this one. That's it. Is it difficult? No, right? So then, so 5. I want 5. is there here? No. Then we will say page part occurred. Then which one to replace? Then first in first out says whichever first came among these things. So this one came, right? This we keep as this and then replace with this one. So that's it. So doing same thing for all these things, okay? So 6 page part occurred. So and then which one came first among these things? 4. So 4, 1, 5. Okay. So 2 is required. So then 6, 2, and then 5. Okay. So next 1 is required. Again page part occurred. Okay. So among these things, which one came first? That is what? 5. Right? 5, huh? Okay. So 1. Remove this one. Okay. So then 6, 2. So 2 is required. There is no page part. 3 we need. So keep as it is. 6, 2, 1. Okay. So then 3 is required. So among these things, which one came first? So before 2. Okay. So 6 came, then 5. Right. 6. 6 came first. So then replace with 3, 2, 1. This is page 1. 7 is required. So 2 came first. 3, 7, 1. Okay. 6 is required. So among these things, which one came first? 1. So then 6, 3, 7. Page part occurred. So and then 2 is required. 2 is not there. Page part occurred. And which one came first? 7. So then 3, 2, 6. So then 1 is required. So among these 3, which one came first? So 3 recently came. Okay. So 2. 2 is also recently came. So then 6. Okay. So then 6 is replaced with 1. Okay. Which is 1. And then 2. So 2 we have already, right? So that's why there is no page part. So then 3 is there. There is no page part. So we need 6, right? So among these things, which one came first? Okay. So after this one, 2 came, right? So 6 came and then 3. Okay. So replace this one with this. Yeah. Page part. So this is what the FIFO. Okay. What I done is, when replacement is required, then I remove which one came earlier, that is removed and placed with the new page. That's it. Okay. So now you count all these things. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So total number of just number of page part is 50. That's it. So this is for 50. Okay. This is what completion of FIFO page replacement will happen. So then how to do the LRU and optimum. So almost the technique how we will vary that one we will see. Okay. Just pause for one. I will do the LRU. So this is over, and now I will do the LRU. So LRU means least recently used. So ಬೇಗ ಕ್ವಿಕ್ಕಾಗಿ ಹೇಳ್ಕೊಡ್ತೀನಿ ಇದನ್ನ. ಓಕೆ. ಸೊ ಯಾಕಂದರೆ ನೀವು ಶಾರ್ಟ್ ಟೈಮಲ್ಲಿ ಸೊ ಬೇಗ ಮಾಡಾಗಿ ಹೇಳ್ಕೊಡಿ ಸರ್ ಒಂದು ವಿಡಿಯೋ ಅಂತೇಳಿ. ಸೊ ಆ ಉದ್ದೇಶಕ್ಕೆ ಮಾಡಿದ್ದು ನಾನಿದು. ಸೊ ಎಲ್ಲರಿಗೂ ಹೇಗೆ ಮಾಡೋದು ತುಂಬ ಸಿಂಪಲ್. ನೋಡಿ ಇಲ್ಲಿ 3 ಫ್ರೇಮ್ ಕೊಟ್ಟಂದರೆ 3 ಫ್ರೇಮ್ ಈ ರೀತಿ ಅನ್ಕೋತಿದ್ವಿ. as in 3 frames, right? So first frame ಖಾಲಿ initially 1 ಹಾಕ್ತೀರಾ. ಓಕೆ. I am doing least recently. So least recently used. Okay. So that is one LRU. Okay. everything note. First time next is on right. So CPU is referencing for this page. Okay, this is also thing. This is page pointer. This is also page pointer. And then so whatever requesting page that is not there, then page pointer is active. Okay. So requesting for 3. 3 is not there in this page, right? So then 1, 2, 3, and then this is for page pointer. Next it is requesting for 4. Right. CPU is requesting for 4. So we can hold maximum of 3 pages, right? So it is filled with 1, 2, 3. Then we need to replace here, right? So then what LRU says? So LRU says that whichever is least recently used, replace with that one. That is what it says. So least recently means what? So see here. So we are here now, right? So just recently used 3. You see the back, that's it. Okay. So recently used 3. So then recently after this one 2. Least recently 1. Just to replace this one. That's it. 1 is replaced with 4. Then remaining as it is. So this is page 1, right? Okay. So next it is requesting for 2. 2 is there. So then there is no page part. Either you can write as it is copy or you can leave it blank. So next requesting for 1. 1 is there? No. Page part after. So at the initial time only it's better to write. Right. So page part after 1. So which one to replace now? See from here just you see the backward. That's it. Recently used 2. So next recent after this one recently means 4. So after that one least recently is 3. Among these things, least recently used is 3. Okay. So then you replace this one. That's it. So 4, 2, 1. Okay. So now it's quite easy, right? Now we can follow all these things for all, right? Okay. So I need 5. 5 is not there in this. So page 5 after. Which one to replace? Recently 1, after that one 2, then 4. Just to replace this 4 as it is 6. Okay. So recently 6 is there? No. Page 5, 1, 2 is missed recently. 1. So next we want 2. 2 is not there. Page 5. So then recently 6. Next 5. Least recently 1. 6. Next 1 we want. Recently is 2. 6. Page 5 after that. 2, 6. Then 5. Replace this 5. So then 6. And 2. Okay. So next we want 2. 2 is there. No page part. 3 is required. So page part after. So recently used 2. Okay. So then 1. Then least recently ಅಂದ್ರೆ ನಾವು ತುಂಬಾ ಅವತ್ತಿನ ರೀಸೆಂಟ್ ಆಗಿ ಯೂಸ್ ಮಾಡಿರೋದು 2, right? So 2 is least recent. Okay, 1 ನಿಮಿಷ. No, it is see here. So 2 is recently used among these one, right? 2 is recently used. After that 1 is used, right? Least recently is 6. So then you remove 6. Got it? Yeah. So then, so 6 is replaced with 3, remaining as it is. Then 7. So among these 3 is recently used. Then 2 is used. Remove this one. 6 we want. 7 and 3 is recently used. Remove this 2. So 7 and 3 as it is. We will replace with 6. So next 3 is required. No page work. 2 is required. Recently used 3 and 6. Then replace this one. Okay. So 2, 3, 6. So 1. We want 1, right? So 1 is not there. Recently used 2 and 3. So then replace this 6 with 1. 2, 3. So then we want 2. 2 is there. Okay, need not to replace. 3 we want. 3 is there. Need not to replace. We want 6. Yes, now we need replacement. Which one to replace? Least recently used. Recently used is 3. So then 2, replace this 1. That's it. So this is what LRU. Okay. So how many number of page parts are there? We need to count it. Okay. So number of page parts. So 1, 2, 3, 4, 5, 6, 7, 8. So 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. Number of page parts. 50. You need not worry about how many number of page part are there, just wait up. Okay. So now, so I think you are clear that just you see the backward, that's it. Okay. Which one is recently and which one is least recently? You replace with the least recently. Okay. So just opposite to that one is optimal page replacement. We'll see now how to do the optimal page replacement. And what is the number of page fault occurs for the optimal replacement? That we'll see now. So now, optimal page replacement algorithm. So this is you can LRU page replacement. So that is least recently used has to be replaced with new page. What is the demand on the CPU? Okay. So in FIFO we have seen whichever first came, so those three we replaced. If it is a 4 frame, then we will see the 4 frames, which one came earlier, so that one replaced for the FIFO. Least recently used as it is, we will see. So in the, if it is 4 frame also, we will do the same thing. So now coming to the optimal, how we will do. In LRU what we done? We see at the left side. In optimal, we will see at the right side. That is the difference. Okay. So we will see now. Say 43 frames I will do here. So very first thing, 1 is required. So that is not there here. Okay. So then that is not there in the frame. So then replacement done. And then page part occur. 2 is required. Page part occur. 1, 2. 3 is required. So there is no here. Page 3. So then we need to update. So page part occur. Then 4 is required, that is not there. Page part occurred. So then which one to replace? The optimal says that. Optimal says whichever is most frequently required. So we want that page so very soon. Okay. And some page we don't want. So we want that later, long back we require, right? So those page has to be replaced here. That is what the optimal says. And then number see here. So I am here now. 4 is required, right? So 3, see 1, 2, 3 we have here. So among these 3, you move early. So then get next future future demand area. So you will see forward here for LRU backward. Forward alone, right? We need very recently 2 is required, right? 2 next step. So don't remove that one. So after that 1 is required. Okay. So 2 bed, other next step 1 bed. So then 3, adadmele for long term bed, right? So then remove this 3. Then we will see it later. Replace this one with 4. That's it. We'll see. So forward. Okay. So 3 take down 4 are remaining thing as it is. Next 2 is required. So that is there. So there is no page part. You need not, right? So then 1 is required. That is also there. You need not to. So replace now. So then 5 is required. Among these things, 5 is there? No. So then page part after. So then which one to replace? Then see among these things, which one is required in the future? We will see for the future here. So 6 is required, means among these 3 only, right? So means 2 is required recently. Okay. So after that one is required. So then don't worry about this 4. Okay. So just replace 4 with so 5. Just remaining thing as it is. I think you got an idea, right? So whichever is required, okay, just you keep those things. Whichever is not required for a long longer duration, you replace that one with the new page. Okay. So then 5 is over now. We will see for the 6. 6 is not there. Okay. Among these three, so 2, 1 recently required. Just you remove this one. 6, 1, 2. So next 2 is there. 1 is there. Again 2 is there. Okay. Now 3 is not there here. Replace. Which one to replace? In future, which one we want among these things? So we want 6 here. So then after 6, we want 2. So then 1. Let's replace this one. 1 with 3. So then 2 and 6. So this is our page 1. Next, 7 is required. So 7 means among these things. Okay. So 6 is required recently. Okay. 6 is required and then 3 is required. So that's why you replace 2 with this. Right. So then 3 and 6. So now 6 is there. Okay. 3 is there. No page part. Then 2. Right. So 2 means which one to replace now? We have here. So then 3 is required here. 6. Okay. 7. See, 7 is not yet required. Okay. So see, we have these things, right? See, here 3 is required, here 6 is required. But 7 is not required. Just to remember this one. Place here 2. Okay. So that's it. So this is also. Just I forgot to write this mark. Page 1 here also. So then this one. Next 1. Okay. So here 1 is not there. So which one to replace now? 2 is required. 3 is required. Just to replace 6. 6 is replaced with 1. 3 and 2 as it is. Okay. So 2 no page part. 3. So then 6 is required. So which one? See, next we don't have anything, right? You can replace anyone here. So it doesn't matter. So you replace just 3, 56, 2, and 1. Yeah. So now what's the total number of page part? So number of page part. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So total number of page parts are 11. Okay. So now number of page part 11, right? 11 page parts. So for the FIFO we got 15. For the LRU we got 15. For optimal we got 11. So andre whichever page reference specific that should be there here, right? So but if number of page part occurs, so then so the delay will be there. Then swapping, that is what replacing with the new one. So lot of things happens inside, right? So that's why when we say which one is the most efficient, then which algorithm has the lesser number of page part, that is the most efficient algorithm. So as of now, among these three, we took only 3 frames here. So for this case, the most efficient one is optimal, right? So here this one is 15 page part, 15 page part. This one is 11 page part. So which one has less number of page part is 11. That is optimal. Is the most efficient algorithm. Okay. So now if you take more number of frames, even though then you may get optimal as so most efficient, or you may get another one. Just check for the other cases with a different example so that you can understand more, right? So then one more thing you can so understand here, because a different type of question they may ask along with these things. So that is hit ratio and miss ratio. So what is hit ratio? Okay. So hit ratio means when we are searching for one page, if we are searching for one, right? So if we found that page, so then that is hit. Okay. If we found page, then that is hit. If we not found that page, if that page is not there, then that is miss. So here we can say we are searching for one that is not there initially, right? So then this is what miss. So and then here searching for two, we didn't get. This is also miss. This is also miss. Okay. So here we are searching for two and we found two here. So this is what hit. Okay. So here we are searching for one, we got that one hit. Okay, one is here, right? We are searching for five, we didn't get. Then this is miss. I think you got an idea, right? So what is hit and what is miss? So then what is the hit ratio and what is the miss ratio? So they may ask. So this is quite simple. For this one I will show you. So hit ratio means what? Hit ratio means how many number of hits are there here. Okay. So this is 1, 2. Okay. So and then 3, 4. So 5. So and then 6. Okay. So and then 7. Okay. So 7, 8. Okay. So total 8 hits are there, right? So that is total 8 hits are there. So among means we can say in definition number of hits by total number of page replacements means this is what whole stream is, right? Total number of pages, right? Means we can take all these things 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay. Total hit plus miss, both the things what we will get. Okay. So total number of strings, that is how much we have 20. Okay. So 8 by 20. So this is what hit ratio. Miss ratio means how many misses are there? Missing. That page is missing, right? That is what miss. So then this is, you can say here it's 11. So 11 by 20 is the